This video is going to show you how to do a scatter plot. I think most of you probably have already done this at some point. However, what we have here, we have two variables that we think may be related. That's height in inches and weight in pounds. So what we're going to do here is let's select our data. We're going to go up to Insert, and then in Insert you're going to see this scatter plot. Left click on scatter plot, and it says what do we want to make it look like. It pops up, and there it is. We see a bit of a cloud here. We have a lot of extra data, a lot of extra white space here, a lot of extra white space there. We can get rid of that white space by left clicking, double left clicking on the over there on our y-axis. It pops up and says, hey, do we want to go from 0 all the way to 180? I don't think we do. I think we could actually start at 120, and that will look better. So I type in 120 and enter. So that helps some of our data. Now if we go ahead and fix our x-axis here, I'm going to double left click on the x-axis. I think we kind of go from about 60 to 80. Let's go ahead and let's just go ahead and make it 60 to 80 here so we can get it in there. Okay, now we have a scatter plot, and this scatter plot is of weight versus height. That's a scatter plot, and the scatter plot's supposed to let your eye look at this cloud and say, is there something in this cloud that makes sense to us? And it looks to me like the taller you are, the more you probably weigh. So there's a relationship there. Scatterplot's not supposed to do anything other than to give you the picture. However, the linear regression part, if we go up here and you left click on the data, you can also right click after you've done that, and you get to add trend line. Adding a trend line over here comes in and says, what kind of trend line do we want? Choose linear. Again, we're looking at a linear regression. You could add these others, but it's much harder to explain to the boss what's going on there. Once we do that trend line, we want to display the equation on the chart, and we want to display the r-squared value, and we'll talk for a second about that. The data pops up, and here's a relationship. It says that y-axis here is weight, x is inches. As you remember, y equals mx plus b. That is our general equation for a line. M is the slope. In this case, the slope is 1.7989. What that's saying is for every 1 inch you go up in height, you should gain about 1.8 pounds. And when you start off, if you were 0 inches tall, you'd start off as weighing 26 pounds as a start. That's the equation that's associated with it. The next thing is the r-squared value. R-squared value tells you how much variance, in this case approximately 60%, of the variability or the variance in weight can be determined by the variability in height. So 60% of the variance here is explained in the variance here. That r-squared there is also very important to us because that is the coefficient of determination, but the coefficient of correlation, which we're all should be very familiar with, is just listed as r, and r is nothing more than equals the square root of the r-squared value, which is 0.6013. In this case, correlation coefficient is 0.77, and that is a high correlation because, as we know from before, 0.1 is normally considered to be a weak correlation. 0.3 is a moderate correlation. And finally, 0.5 is a strong correlation. Last thing that we'll talk about on this correlation is we know that this is positive. This is a positive relationship. It could be negative, or in some cases the correlation coefficient is very close to 0, which means there isn't much of a correlation at all. So there you have it. That is both a scatter plot and linear regression.